Hi everybody, welcome to lesson 2.1, Relations and Functions. We're going to discuss what is a function and how can it be represented. The first thing we'll talk about is a relation. A relation is a set of all ordered pairs that can be written x comma y. What you see here is our very own XY table. So if I wanted to go ahead and write this table as a relation, what I would want to do is pair up each X and Y value to make an ordered pair. And we would start off by writing those as a set in curly braces, and then I can just start writing down each ordered pair that I see. So my first ordered pair is 5 and 19, followed by 10 and 3, continuing on down my list with 15 and negative 5, and so on and so forth until I get to my last ordered pair, 30 and negative 18. Always remember, when you write ordered pairs, the X value always comes first, followed by your Y value. Some things that we want to talk about when we're dealing with relations, or when looking at our XY table as we have it here, is the difference between the domain and the range. The definition of the domain is the set of all X values in a relation. So looking at our table that we have, all of my X values that you see going down the left, these are our domain. And what we would want to do is write those X values in order from least to greatest as a solution set. Next, we'll talk about the range. The range is the set of all of our Y values in a relation. And we will also write our range out in order from least to greatest, as you can see. So we've been able to take our XY table and we've been able to write that table both as a relation, as the set of X and Y ordered pairs, and separate our relation into the domain, which is our X values, and the range, which is our Y values. The next thing we'll want to talk about with a relation is whether or not we can classify a relation as a function. A relation can be considered a function if each value in the domain is paired with exactly one member of the range. So what this means in terms of our examples, if you look at our first example here, you really just want to look at your domain. So values on our domain include negative 3, positive 4, and positive 2. We would consider this relation to be a function because each X value or each value of our domain is different. Looking at example number 2, you will see that we have positive 4 as a repeat in our domain for the first two ordered pairs. You never want any of your X values to repeat, so that makes this example not a function. Moving along, another method to be able to tell if a relation is a function is through a vertical line test. Now, the vertical line test will let us know if we have a function by looking at the graph. So the vertical line test allows us to draw a vertical line through a graph to determine if it passes through exactly one point on our graph. Here are some picture examples we're going to go through together using and demonstrating the vertical line test. In the first example, I'm just going to pick a spot on my graph, draw a vertical line straight through it. When this happens, you'll notice that my blue line that I've drawn has gone through more than one point on the graph. It's touching two parts on my pink parabola. That means that this first graph is not a function. When you have a vertical line, all values on a vertical line are x values. So this goes against our understanding that we're not allowed to have any x values that repeat on our graph. Moving on to the green parabola, if I pick a spot to draw a vertical line, now my vertical line only touches my parabola in one spot. So I'm going to answer that yes, this parabola is a function because my vertical line only touches one point on the graph. At this point in the video, you can pause and do a self-check for yourself on the last three graphs. See if you can determine if these three graphs are functions. When you hit play again, then we will go over the correct answers. Welcome back. You can now check your answers to the last three examples. We have, for the example that we left off with in the middle, yes, this graph is a function. My next graph is not a function. And the final graph, which is just a set of points that have been graphed, this picture is not continuous because the points are not connected together. So as you can see from my picture, I had to draw vertical lines through each point because they were discontinuous to check to see if each point allowed me to be a function. My answer to this was yes, because each line that I drew only went through one point. A counter example to this would be if I had, say on this first point here, a second point that was just exactly over top of it. If I can get my pen to work, maybe. I guess not. Let's say I had another point just above here, then that would not allow my graph to be a function. Last thing we want to talk about in lesson 2.1 for today is how to evaluate functions. We learned back in chapter 1 that evaluating typically means that we're going to take some sort of value, substitute it into the problem that we've been given for the given variable. So starting first with my function f of x equals 3x to the third minus 7x squared minus 2x, and we've been asked to find f of negative 4. This means every time I see an x value in my function, I'm going to be replacing that x value with a negative 4. So I'm going to start by rewriting my function, which was f of x, with f of negative 4. This goes to show that everywhere there was an x, it will now be replaced with negative 4 instead. Once all my variables have been replaced with a negative 4, I'm going to go through and practice my order of operations. So always beginning with my parentheses and exponents, I'm going to take negative 4 to the third power, which is going to give me a negative 64. And I'm bringing down my 3. Next up, I'm going to take negative 4 to the second power, which is going to give me a positive 16. And lastly, negative 2 times negative 4 is going to give me a positive 8. Continuing down to my next line with my order of operations, next comes multiplication. 3 times negative 64 is going to give me negative 192. Negative 7 times 16 is going to give me negative 112. And I'll just bring down my plus 8. And lastly, I'll combine all of my values together to get a final answer that f of negative 4 is equal to negative 296. You can pause the video one last time and try example number 4 by yourself, in which you'll be finding g of 9. And you can now check your final answer to problem number 4 with my own work. You should have gotten a final answer, g of 9 equals 438, and I have all my steps there shown along the way. That's all for this time for lesson 2.1. See you in lesson 2.2.